All right, so we are doing the Algebra 1, Chapter 3 practice test. If you are watching this and you're in my class, if you can do everything on this worksheet, you can do really well on tomorrow's test, as long as you don't just make those little mistakes. So the first thing we talked about in the beginning of this unit was determine if the graph is a function. And when we're looking at a mapping like we have here, we're looking to make sure every x value has one and only one y value. So 11 has the output of 7, 15 has the output of 8, and 22 has the output of 7. They each only have one output for this input. It's okay that two inputs share an output, but it would not be okay if 22 also had an output of 8. So this one is a function. So we can write yes. And then we also have a vertical line test to determine if a graph is a function. If I draw a vertical line anywhere and the graph touches more than once, it is not a function. So this, you can see, touches this vertical line more than once, so this one is not a function. And if I look at this graph, the third one, this parabola, I can draw lots of lines through here, vertical lines, and none of them touch the parabola more than once. So that makes this a function. Number 2, evaluate each function when x equals -5. So to evaluate means to plug that number in and then determine what it equals. So f of -5 equals -4, replacing the x with -5 minus 7. Now this part here, f of -5, just means the function called f, which is what we're plugging into. When I plug in -5, is going to equal whatever I get when I do this. And we have -4 times -5. Negative times a negative is positive, so this is positive 20 minus 7. So f of -5 equals 20 minus 7. So f of -5 equals positive 13. And that's your final answer. You don't need to, you're not solving for anything here because f is not a variable. So you're just saying the function f, when -5 is plugged in, is equal to 13. Letter B, g of x. G is the name of this function because it's different from the one in A. So we're going to find g of -5, and that's 2 times -5 squared. Now the order of operations says parentheses, but parentheses means do what's inside the parentheses, and there's nothing to do inside the parentheses. There's just a -5 in there. That's all we have inside is the -5. So then the next step is to do the exponent. Exponent comes before multiplication. So that's 2 times -5 squared, which is positive 25, because a negative squared is positive. And 2 times 25 is 50. And so that gives me g of -5 equals 50. Okay, it's really important, especially on tonight's test, tomorrow's test, that you show your work. Okay, if you just write 50, you're not going to get credit. I want to see how you plugged it in. And then lastly, h of -5. That's -x. X happens to be a -5 minus 6. Now this negative and a negative become positive, so that becomes 5 minus 6, which is -1. So h of -5 equals -1. And these are our final answers. Number 3 is find the range for the given domain. So the range is my output when I put these numbers into this equation. So we are going to plug in -2. G of -2 is -5 times -2 plus 3. Negative times negative is positive, so that's positive 10 plus 3. That's 13. So g of -2 is 13. The next one is g of 1. G of 1 is -5 times 1 plus 3. Negative times a positive is negative, so -5 plus 3. G of 1. And g of 1 equals -2. And then plug in 3, g of 3 is negative 5 times 3 plus 3. So g of 3 equals negative 15 plus 3, and g of 3 equals negative 12. So I found what all of my values are, but I haven't actually said the range yet. So my range are all of these together, 13, negative 2, and negative 12. I ran out of room for my curly brace. Move everything over. I'll draw my curly brace there. And so that is our final answer, writing them all together as a range. All right, so the next thing is finding our graphing by finding the x and y intercepts. Now remember that on a coordinate plane, our x-axis is horizontal, and all of the points on this axis have a y value of 0, and our y-axis is vertical, x and y, and all the x values on the y-axis are 0. So to find my x-intercept, I'm going to plug in 0 for y. So 6x minus 5 times 0 equals 30, and 6x equals 30. I solve by doing the opposite of multiply, which is divide. So x is equal to 5. So my x-intercept is 5, 0. It's an ordered pair. I like to write it that way, so I remember that it's its own point on my graph at 5, positive 5, 0. Then if I want to plug in 0 for x, that gives me the y-intercept. And that's negative 5y equals 30. Divide by 5, negative 5, and y equals negative 6. And that's the point 0, negative 6. So that's 1, 2, 3, 4, 5, 6, negative 6 on my y-axis. So there's my y-intercept. And then now that I have 2 points, I can draw my line connecting my 2 intercepts. Okay. Let's look at number 5. I'm going to do some of the work down here because it's getting a little crowded over there. So 2x plus 4 times 0 equals 16. So 2x equals 16, and x equals 8. So that x-intercept is 8, 0. And then the y-intercept is 2 times 0 plus 4y equals 16. So we're plugging in 0 for x to find y, and plugging in 0 for y to find x. And our intercept is the variable that we are solving for. So here we're solving for y. We divided by 4 because it's 4 times y. So y equals 4. 0, 4 is our ordered pair. And we'll draw a little graph here. 8 and 4. Let's put 8, 0 on there. And let's put 0, 4 on there. And this is our line for number 5. Okay. Let's move some of this out of the way. Let's see. Let's just delete some of this out. You can always rewind the video if you want to see that part again. I'm just trying to make some space. Okay, let's look at number 6. Same idea. I want to find the x-intercept. I'm going to plug in 0 for y. Negative 3 times 0 equals 12. And 6x equals 12. 6 times x, so divide by 6, and x equals 2. And it was 2, 0 is my ordered pair. And then to find the y-intercept, plug in 0 for x, so 6 times 0 minus 3 times y equals 12. That's negative 3y equals 12. Divide by negative 3, and y equals negative 4. And that's 0, negative 4. And then on a graph, And I'm drawing these a little small. You'll have a nice big little section of graph paper on the test tomorrow. So -4, +2. So +2 is my x-intercept, -4 is my y-intercept. Remember, there are two separate points, one of them on the x-axis and one of them on the y-axis, and we connect them to draw our line. Number 7, the x-intercept, plug in 0 for y. 4 times 0 equals 12. X equals 12. Okay, plug in 0 for x to find the y-intercept. So 0 plus 4y equals 12. 4y equals 12. Undo multiplication by dividing. Divide by 4. Y is equal to 12 divided by 4, which is 3. So my y-intercepts are 12, 0, and 0, 3. My x-intercept should always be on the x-axis. Eek, all the way over there. And my y-intercept is on the y-axis. And I can connect them. Ran out of space. The next thing was graphing using slope-intercept form. Slope-intercept form is y equals mx plus b. M is the number is the slope, which is the number in front of the x value, and b is the y-intercept. Now we just did x and y-intercept. The y-intercept crosses the y-axis, and the number one mistake students make when they're graphing these functions is they put the y-intercept as an x-intercept instead. So for number 8, my slope is 2/3, and my slope is like directions to the next point. So I'm going to start at my y-intercept of b equals -4, and my slope tells me to go up 2 and to the right 3. Now we have to remember that slope, if it's positive, it's going to go up from right to left, and if it's negative, it's going to go down from left to right. We read graphs like we read a book. So positive is going up from left to right, and a negative is going down from left to right. We're going to use that to make sure we graphed it correctly. If our slope is negative, it should be going down, because a lot of students do the wrong direction with their slope, and they end up with a positive slope when it should be negative. So here we have a slope of 2/3, and we start at -4 on the y-axis. -4. Let's do this in a different color. And we're going to count up 2. So we're going to go up 2, and we're going to do the right 3. And that's where our next point is. And then we can go again if we wanted. Up 2 and to the right 3. I didn't put any lines there. And then we connect our points. And this line is going up from left to right, so it's positive, as it should be, because our 2/3 is positive. Let's look at number 9. Y equals -6x plus 9. So my slope, m, is -6. When it's a whole number, we put it over 1. And this means when it's negative, we're going to go down 6, and we're going to the right 1, okay? I try to always go to the right, that way up or down gives me my negative. If I go down and to the left, I go negative, and a negative times a negative makes a positive slope. So that doesn't give me the negative that I want it to be. Okay, so always try to remember, go to the right, unless you have to go the opposite way. And then my y-intercept, b, is +9. So we're going to draw our little coordinate plane, 2, 3, 4, 6, 7, 8, 9. And like I said, on the test, you're going to have a nice little segment of graph paper for you, coordinate plane. I'm going to start at +9, and I'm going to go down 6, 1, 2, 3, 4, 5, 6, and over 1. And then I'm going to connect it. I can do it again if I want. But again, this line is going, this line is going down from left to right. That's not a very good arrow. How about, no, the arrow doesn't change. So this is going down from left to right. This one's going up from left to right. And that's how we make sure the slope is correct. It's a negative slope. It should be ending down. Number 10, y equals x plus 5. My slope, when there's no number in front, there's always an imaginary 1. When it's a whole number, we put a 1 underneath it. And this means we're going to go up 1 and to the right 1. And then my b is 5. So we're going to start my graph at positive 5 on the y-axis. The y-axis is the vertical axis. And we're going to go up 1 and over 1. So we're going to go up 1, over 1, make a point. Up 1, right 1, make a point. And we can keep going and connect. Again, this graph is going up from left to right, so we did it correctly because our slope is positive. Let's move everything over, throw number 11 on here. Oops. Number 11, y equals negative 1/5 x plus 4. My slope is the negative 1/5 x. So m equals negative 1/5. That means I'm going to go down because it's negative and to the right 5. And my y-intercept is 4. So we're going to start on the y-axis. Always the y-axis when you're in slope-intercept form. The point 0, 4, that's what that represents. And I'm going to go down 1 and to the right 1, 2, 3, 4, 5. I forgot to put that many lines. Okay, and then we can do it again, or we can just connect the two. Slope is negative, graph is going down from left to right. So that's what we're looking for. That's how we can check to make sure we did it right. Now we want to take equations that are in standard form and put them into y-intercept form, then graph them. So number 12, I want to get y by itself because remember our slope-intercept form is y equals mx plus b. This is the most common way you'll see teachers graph a line, by putting in the y equals mx plus b form. So subtract my x, y equals negative x plus 1. So this means my slope, m, is negative 1, and my y-intercept is 1. Put that on a graph. Positive 1. Remember a slope of 1, we're going to put a 1 underneath it, and we're going to go down and to the right. So from positive 1, I'm going to go down and to the right 1. Do it again, down and to the right 1. And there's my line. Negative line, it's going down. Number 13, we're going to subtract 2x from both sides. So I get negative 7y equals negative 2x plus 14. I like to put the x in front of the constant so it looks like y equals mx plus b form. To get rid of the negative 7, I'm going to divide by negative 7. Pay close attention to your negative signs. That's one of the places where lots of students make mistakes. A negative divided by negative is positive. A positive divided by a negative is negative. So we get positive 2/7x minus 2. My slope is positive 2/7. So I'm going to go up 2 and to the right 7. And my y-intercept is negative 2. These are very rough graphs. Okay. 1, 2. Started at -2 on the y-axis. I'm going to go up 2, and I'm going to go right 7. And then I can connect them. Up, positive slope, going up from left to right. Number 14, I'm going to subtract x. Negative y equals negative x plus 5. Divide by the negative, or the -1, because y has to be positive. So negative x divided by -1 is a positive x. 5 divided by -1 is -5. So my slope is 1/1. It's always that imaginary 1 if the x is by itself. And my y-intercept is -5. So I'm starting on the y-axis at -5. And I'm going to go up 1/1. I'm going to go up 1/1, make a point. Up 1/1, make a point. And I can keep doing it as long as I want, but I can connect after 2 or 3. Again, slope is positive, line is going up. That's always should ask yourself that at the end. Is my line going in the correct direction? And number 15, subtract 4x. We get 7y equals -4x plus 35. To get rid of the 7, we're going to divide by 7. So we get y equals -4/7 x plus 5. And our slope is -4/7, so that means I'm going to go down 4 and to the right 7, and my y-intercept is +5. So up 2, 3, 4, 5. I'm going to go 0, 5 on the y-axis, and I'm going to go down 4, 1, 2, 3, 4, and over 7, 2, 3, 4, 5, 6, 7. And connect it. Negative slope, and my graph is going down. All right, the next thing we looked at is finding slope. We actually did this before we did the slope-intercept form, but that's okay. I have 2 points identified on this line. Now my slope formula is, we can find m. It is the rise over the run, and we saw that as I was graphing. I went up or down for the top number and right for the bottom number. So I'm going to start on the leftmost point, and to get to the other point, I'm going to count how many I have to go down and how many I have to go over to get there. I went a little far on that. So let's count this. Let's use this. 1, 1, 2, 3. And I'm going down, so that's negative. -3 is my rise, sorry. And my run is 1, 2, 3, 4, and 5. So -3/5 is this slope. Now that's great if I have a graph and 2 points that I can find, but sometimes I don't have that. And I need to use coordinates to find my slope and y-intercept. So if we have x1, y1, point 1, and x2, y2, point 2, we can use the formula change in y, y2 minus y1, divided by the change in x, x2 minus x1. It's really important that if we start with our y2 on the top, we start with our x2 on the bottom. That way our sign is correct. So we can define this point as x1 and y1, and this point is x2, y2. So for number 17, I get 9 minus 3 divided by -4 minus 6. Right, 9 minus 3, -4 minus 6. That's +6 over -10. And that can be reduced to -3/5. And we normally put the negative in the numerator. It doesn't make a difference. We put it in the numerator or off to the side in the front. So this one also has the slope of -3/5. Let's look at number 18. Same thing, x1, y1, x2, y2. So y2 is 0 minus -8. Really important. We put those parentheses there because that's going to become adding. And then y2, -4 minus -8. This becomes plus a positive on the top. We get 8. Becomes plus a positive on the bottom. -4 plus 8 is 4. And 8 divided by 4 is 2. So our slope is 2. All right, the next thing was describing transformations. And this can be overwhelming, but really the only thing we're interested in is looking at the bottom part, because that's what's going to happen or be done to the function above. And it doesn't really matter what the function above is, because the transformation is going to be the same. So when we're inside the either the function or the parentheses, whether it's absolute value or squared, when I go inside, it's a horizontal translation. It moves it right or left. Okay, when it's outside the function, it moves it up or down. Up for positive, down for negative. Now, these ones are kind of funky when it comes to being inside the function, because for f of x plus 2, even though we want it to go positive 2, it's actually going to go -2, which is left 2, because -2 is what makes the inside of the function equal to 0. And so it moves the function to where the x is equal to 0 inside here, and that would be -2. And then the -5 on the outside moves it down 5. So your answer is left 2, down 5. Now when we're multiplying by a number in front of the function, like here in number 20, if the absolute value of the number in front, we label that a, is between 0 and 1, we call it a shrink. And if the absolute value of that number is greater than 1, it is a stretch. And it's the absolute value because the negative does something different. The negative flips it upside down, and that's called a reflection. So for number 20, 5/6 is a shrink. And so it's a shrink of 5/6. Number 21 has a lot going on here. 4 f of x minus 8 plus 3. When I describe these, I always start with what's happening inside the horizontal right and left. So if it's -8, what makes this equal to 0 is +8. So +8 is to the right 8. And then the number on the outside, this 4, is a stretch. Well, let's first talk about that +3. That goes up 3. And then it's a stretch of 4. And if we can think of it in this order, it's going to help us graph them faster. So it's right 8, up 3, and a stretch of 4. And number 21, -2/5 f of x plus 7 minus 2. Again, what's going on inside here? What makes this equal to 0 is a -7, so that makes it left 7. The -2 on the outside makes it go down 2. The 2/5 is between 0 and 1, and that makes it a shrink of 2/5. And this negative makes it a reflection. Okay, so what's left or right, what's inside? Up or down, the number added on the outside. Shrink or stretch, and then the negative makes it a reflection. So there's some vocabulary there. Okay, here's some graphing absolute value functions. Number 23, I want to look at what's going to make the inside 0. So we said you can make a table, but you at least need to figure out what makes the inside 0 and plug that in. What makes that 0 is 2. And when I plug that in, I get the absolute value of 2 minus 2 minus 6. That's the absolute value of 0 minus. So my y value is negative 6. And so that's where I'm going to start my graph. Okay, now this is the quick way to do it. If you want, you can plug in the numbers 3 and 4. You can plug in 1 and 0. So positive 2, negative 6, that's where my vertex is going to be. And there is no vertical shrink or stretch on this. There's no number being multiplied on the outside of the function. So the slope of this is 1, which we always make as a fraction, 1 over 1. So these graphs are always going to be a V. If there is an absolute value function that you have to graph, the look of it will always be a V. So we go up 1 and to the right 1. So we go up and to the right because our slope is 1. And then we go up and to the left. That gives us the negative part of the V. So we get these 2 points, and we can do it again. We can do it again, and we get this V. So let's look at number 24. 24 has a vertical shrink of 1/5, and it has a reflection. So what makes the inside 0 is 0 because there is no left or right movement. X is all by itself, so 0 makes that 0. The absolute value of 0 times negative 1/5 is still 0 plus 4, so this graph is at 0, 4. And if you think of our translations that we just talked about, this graph gets moved up 4 from the origin. And this graph, the first one here, this graph got moved right 2 and down 6 from the origin. So this graph is going to start at 0, 4. Let's do it in this color. And the slope is negative 1/5. So we're going to go from my point down 1 and to the right 5. That gives me the positive branch. Down 1 and to the left 5. That gives me the negative branch. So down 1 and to the right 5. Down 1 and to the left 5. And this graph is nice and wide, and that's a vertical shrink. Oops, wrong key. All right, let me move some of this out of the way. Number 25. What makes the inside here 0 is a negative 1. When I plug in negative 1, I get negative 1 plus 1 minus 6. And that's negative absolute value of 0 minus 6. So negative 1, negative 6. This graph moved left 1 and down 6. And it's a reflection in the x-axis. So it's going to be upside down. So my slope here is negative 1 over 1. So my graph is going to start at negative 1, negative 6. This point here, and a negative slope of negative 1 means I'm going to go from my vertex down 1 and to the right 1. That'll give me my positive branch, or my negative branch, and down 1 and to the left. That'll give me my other branch. Down 1 and to the right, down 1 and to the left. And that is my graph for number 25. And number 26, let's get this out of the way. What makes the inside here 0? Positive 2, so that's the middle of my table. If you like the table method, you can do that. We're going to plug it in. 4 times 2 minus 2. Minus 3, 4, absolute value of 0 minus 3 is negative 3. So this graph is to the right 2 and down 3. Right 2, down 3. And my vertical stretch of 4 means my slope is up 4. and over 1. So from here I'm going to go up 4, 1, 2, 3, 4, and to the right 1, and then to the left 1 to make my V. So let's get another point there. So up 1, 2, 3, 4 over 1, and then to the left 1. Connect. And there's my absolute value function. All right, last 4. Describe the transformation on the graph. Now you can look at the equation, but we're comparing to the point 0, 0. Okay, so where did this graph get moved from 0, 0? This graph moved to the left 4, and it went up 4. So number 28, we got to be careful with our scale here. Let's see where it moved. Looks like it's in between the 2, and this is 2 and 4, so this went to the right 3. It went up, it looks like that's at 5, so it went up 5, and the numbers in our equation should confirm what we're seeing, what we're writing. And then the negative, it's reflected, so it's reflected. And that's all we need to write. Right 3, up 5, and reflected. Number 29. Went to the right 3 and up 1. You see it? From the origin here, it went right 3, up 1. And then lastly, number 30, all it did was move down 2. All right, guys. Good luck tomorrow. I hope this was helpful. Like and subscribe.